Hello 30-1. So we begin lesson 1 with dealing with specifically, and we talked last day in our introduction about um, speaking about radical functions. And in this unit there's going to be radical in two different ways. There's going to be radical functions where we have y equals the square root of x, but there's also going to be the square root of a function. And we'll make that clear as we complete lessons 1 and 2. Um, and we'll also, at the end of this unit, talk about solving equations with radical and rational functions. So in this one, we're just going to deal with specifically the simplest of radical functions, which is just the square root of x. And during this unit, we're going to remind ourselves of our transformation units with our transformations of k, a, b, and h. Now, if we look at the critical points for a square root function, we can see that the square root of -4 is undefined, or 2i. It's an imaginary number. The square root of -1 is I. The square root of 0 is 0. The square root of 1 is 1, and so on. Okay. Just a quick little reminder on the side here, and this is the most screwed up concept at times, even in textbooks. Even a lot of educators don't always do this right. That if a person was asked the question, x equals plus or minus square root 4, you would put plus or minus 2. But here's two different questions that are screwed up. When somebody asks you if x squared is 4, and it's the million-dollar question, you must answer x equals plus or minus 2. Most people will only answer 2. And the reason that you must answer plus or minus 2 is when somebody has asked you x squared, both plus and minus 2 work. However, if somebody says x equals the square root of 4, that particular question only has one answer because they were only asking for the principal square root. When somebody asks you for x squared equals 4, you need to take the square root. And so when you take the square root, as we flow this way, plus and minus square root 4, your answer for this is plus or minus 2, but for this one it's only 2. We need to make sure we're clear of that difference. We're asked for an explanation of why the domain is not the set of real numbers, and obviously because you can't take the square root of a negative. The square root of a negative is undefined. To state the domain of that, obviously I kind of misplaced that. It belongs here, and it is x such that x is greater than or equal to 0. The range would be y such that y is greater than or equal to 0 as well. And a little note on the side, I was just discussing the difference between y equals square root x and x equals y squared. And again, it goes back to that concept we talked about before about who takes the square root. This function here, although it does turn out to be the same. If you solve this for y, you end up with y equals plus or minus the square root of x. So in this function, number 2, it has 2 branches, and there's a major difference. Okay, and again, we're just talking about what would the difference between y equals square root x be and y equals square root x. If I made a little bit neater graph, y equals square root x would just be the positive square root of x, like we looked at that table of values up above. But if somebody asked you to graph, x, I'm going to color straight here. If somebody asked you to graph x equals y squared, you would take the square root of both sides, and you would graph y equals plus or minus square root x, which would give you both a positive branch, square root x, but it would also give you the negative branch, which would be y equals minus square root x. So just a little bit of clarification on positive and negative square roots and the operation of taking square root. Okay. The rest of it, once we've established those critical points, and I'm just going to go back here and circle these. If you're going to graph a square root function, all you really need is this point and this point and this one. Those 1, 2, 3 critical points. Your job for the rest of the assignment is simply going to be using our HK, A, and B transformation. How do I transform those using SRT? All right, and making sure that you remember the things we talked about before. So a little note, I guess I'm probably going to remind you of this every time we talk, that if you don't factor a B value out, you're pretty screwed. Okay, we have to remember to do that on a regular basis, otherwise it's going to mess us up. So if I was to complete the transformation of example 1, first off, we describe what the series of transformations is. Well, it would be a horizontal translation 2 left, and vertically it would be 4 up. Second thing was make a rough sketch. So if I made a rough sketch of that over on the side, I first started off by graphing my critical points for my graph that we talked about. I'm just going to circle them in red, 0, 0, 1, 1, 4, 2, and then I simply move everything over. And one of the ways, and I might have mentioned it before, that I take care of business is if I know my critical points, I can just draw what I call crosshairs, imaginary set of axes, and I move what used to be the origin here, and I just set up a new set of axes over here, and I now graph on this new axis 0, 0, 1, 1, and 4, 2 on this new axis. Instead of moving every point, I just graph my critical points over there. Next thing, I know that I can't take the square root of a negative, so I ponder x plus 2, and I say the smallest number that I could possibly put in there is minus 2, because that square root would be 0 at that point. Or it might be that that a student like Chris says, well, I'm just going to look at my graph. I've graphed it already, and so I can see that my domain is x is greater than or equal to negative 2, and my range is y is greater than or equal to 4. All right. On the bottom, I've shown my transformations of my points, and depends on how you want to do it. It says verify it using graphing calculator, and I did because I'm smart. And we continue on with our other, we continue on with our other transformations, okay? So I didn't do a really accurate, with my points. I could, but I would like you guys to complete that. My challenge to you would be make sure that you can come up with those critical points, right? Can you come up with the critical points that we had, again, and this would be my challenge to you, 0, 0, this is y equals square root x. So my challenge to you would be, under each of these transformations in B, C, and D, could you take 0, 0, 1, 1, and 4, 2, and do each of the transformations in B without using your graphing calculator? Sorry, in B, C, and D. All right, I know you can use your graphing calculator, and you wouldn't have to really know anything. I could get a grade 10 student to look at their table of values, but I really want you to be able to do this on your own, okay? So obviously in question B, this graph, right? Obviously in question B, this graph was vertically stretched by a factor of a half. So if I do SR and T, so it should be half as tall. All those points would be half as tall, right? And then it's reflected in the y-axis, so that graph would now be over here. And our domain and range is given there. In the C, it's reflected in the x-axis, vertically translated 5 down, so there isn't any stretch. So it's the same graph, just reflected down, and then it is, as we showed here, moved down 5. In D, again, please don't forget to factor. So if you factor that out, I said, can't trick me, horizontally stretched by a half. So if you look at my blue graph over on the side, I have horizontally stretched it by a half. And then it's a horizontal translation of 1 unit, of a half a unit to the right, and there's my domain. X is greater than or equal to a half, and Y is greater than or equal to 0, okay? So again, if you just look at what I didn't do it in all these, but if you look at example D, please look at my table of values. This is what I'd like you to be able to do. That if you look at my black numbers, those were my original critical points for a square root function. Can you stretch those points with, if you look back, we had a horizontal stretch by a half and a vertical stretch by 3. And if you look at what I did, 0, 0 is an anchor point. They don't change at all. But if I stretch this point by a half and 3, it becomes a half and 3, and 4, 2 becomes 2 and 6. So those points have now been stretched, and all we have to do is a horizontal translation a half right, and now we have our exact critical points. And again, Graham might say that, but Mr. K, I can just plug them in my calculator, but they're not going to ask you a question like this on a diploma. They don't want to give you opportunities to let the calculator be the brains. They want to see how brilliant you are. So it's really about using our transformation skills, okay? They're not going to give you a question that you can just type in your calculator, okay? Lastly, this is more like, this is more like a diploma question where you just get some variables, and now they're looking for you to kind of self-explain and see whether you really do understand what this is all about. So if A was greater than 0 and B was greater than 0, what would the domain and range be? And this might feel awkward to you, but you need to be able to do questions like this. If we can't, we're going to miss quite a few questions on the exam. And probably the best thing that you could do if you're looking at ways of cheating, and by that I mean just understanding it in a better way, if A is greater than 0 and B is greater than 0, you have no idea how much it's stretched up and down, left or horizontally, but you know you've got a square root function that looks like that. Because if A is greater than 0, it is stretched vertically, but it's not reflected. And if B is greater than 0, it's not reflected. So it's going to stay in that way, but it might look like this or it might look like this, but it's going to be that way. So there is your domain and range no matter what. If A is less than 0, then it has been reflected in the x-axis, so it's going to be a down, but on the right side. So it's one of those, or one of these, or one of these, but it's over there. So y is less than 0, but x is greater than or equal to 0. If the A is positive, but the B is negative, well, ponder to see, well, where would that one be? Where is that particular square root function? Well, that particular square root function must be in quadrant 2. And if it's in quadrant 2, then that would be my domain and range. And lastly, again, a little bit higher level question. If they're both negative, then it's in quadrant 3, and it's one of these, or maybe even this. But it is clearly in that quadrant, and that would be my domain and range. So that's a little bit deeper into functions. And again, example 2 is the kind of question they want you to think of. A more general type of question, not something that you would just graph. But like I said, you could, and you're welcome to, anytime they have things like this, don't freak out too much, just pick numbers. Just pick numbers that work for that. And so for example, in C, you might pick, well, A greater than 0, maybe I'll put A as 2. Square root of B is less than 0, so minus 5x. It wouldn't matter what number you pick, you're just picking something like that to see what happens. And then you could graph it on your calculator. Okay, carry on with lesson 1, and we will talk about lesson 2 shortly.